Hello students, welcome to Chemistry Bench. So in this video, we are going to see top 5 chemistry questions every NEET JEE student gets wrong. So let's get started with the first question. The first question is related to mole concept, and sometimes there is limiting reagent confusion. So let's see the question first. So in this question, the mass of both the reactant hydrogen and oxygen are given, and we have to calculate the mass of product. So we know that in the first step, we calculate the moles of the reactant, like moles of hydrogen and moles of oxygen, and we try to get the mole ratio from the stoichiometry of the balanced chemical equation. So we can see that according to the stoichiometry of the balanced equation, the mole ratio of hydrogen and oxygen is 2:1, and the given moles is in perfect ratio, right? So in such a question, we see that there is no limiting reagent, or we can see that both the reactant reacts completely. Okay, so in that case, we can use either the mole of hydrogen or the mole of oxygen to calculate the mole of product. So as in here, we have used the mole of hydrogen to calculate the mole of product. So common mistake often made by the students is that they assume that one reactant is always limiting, and they unnecessarily divide or multiply by 2 again. So next time when you come across such a perfect ratio between the reactants, just make sure that you are not unnecessarily using or multiplying or dividing by the coefficient. So the next question is another question, which is a thermodynamic based question. So first, let's see the question. So in this question, we have 2 moles of an ideal gas that expands isothermally and reversibly with a change of volume from 10 liters to 20 liters. So we can directly apply the formula to calculate the work done. Okay, and the common mistake which the students do make is that they often forget that the work done by the gas is negative. So students, you always should be aware of the sign convention. You should know that work done by the gas is negative and work done on the gas is positive. So this is another question which is based on Nernst equation. So let's see the question first. So in this question, we have to calculate the molar concentration. We have to calculate the electrode potential of this half cell. So we know that the standard potential is given. So using the Nernst equation, we have this formula. So the common mistake made by the student is that instead of plugging in the value of the zinc concentration, they instead of plugging in the reciprocal of the concentration, they directly plug in the value of the zinc concentration, molar concentration of zinc, and that is how the answer goes wrong. So students, be aware of this fact. So when you have to plug in the reciprocal into the Nernst equation. The next question is based on equilibrium. So in this question, we have to calculate the molar concentration of the product ammonia at equilibrium. So while solving, we'll use the expression for the equilibrium constant, and we can use the ICE table to calculate the equilibrium concentration of the reactants, and we can plug in the formula for the equilibrium constant here. So the common mistake in this question made by most of the student is in the approximation done. So let's see what is the approximation here. So if we consider that the excess mole, and we can approximate this to 0.2 raised to the power 4 and calculate the answer. And so the common mistake here is not checking if X is eligible is negligible before approximation or not. So the fact is that we can only consider x to be small when it is usually smaller than 10 raised to the power minus 3 molar. So x should be tiny compared to the initial concentration, then only we can neglect that value. Or there is another rule which is called the 5% rule in order to check if the approximation is valid. So in this rule we try to check whether the change x is less than the 5% of the initial concentration. So this is called the standard 5% rule. So here in this question we can see that the initial concentration is 0.2. So for the reactant it is 0.2. So if the change, we calculate the percentage of change with respect to the initial concentration, and it comes out to be 0.1265%, which is less than the 5%. Hence our assumption that x is negligible is valid here. So because this ratio is less than 5%, so x is negligible and our assumption is correct. But if this ratio had been greater than 5%, then we have to plug in the value of x as well and solve the full cubic equation in order to calculate the value of x. This is another question from atomic structure. So when we have to calculate the de Broglie's wavelength, so in that case we can easily plug in the values given in the question for the Planck's constant h, mass of electron and the charge of electron. But the common mistake most of the student makes in such question is that they forget the square. So students, be aware while using the formula, so do calculate the square root so that your de Broglie's wavelength come out to be correct. And one bonus question to look at the mistake. So in some of the questions where we have to calculate kilojoules per mole, like in this question, the enthalpy of the reaction is given in terms of moles of ammonia. So students, they directly write delta H, reaction is equal to minus 46.2 kilojoules without considering that it is for the moles of ammonia, and they do not consider that in the reaction 2 moles of ammonia are produced. So the correct calculation should be 2 times the enthalpy given, because it is for the moles of ammonia. So that was all for today. I hope you enjoyed this video. Do share and subscribe. Thank you.